So thanks for coming. I know it's already late, even though it's not the last session. This is joint work with Avinatan, Hassidim, and Shorrer. Let me start by asking you, what did you do when you woke up this morning? I bet most of you brushed their teeth, hopefully, drank their coffee, dressed up real nice, and came here to hear exciting new talks about equilibrium computation, about multiple buyers buying multiple units from multiple sellers with multiple fingers, I don't know, and matching theory. That's not what I did this morning. So when I woke up at 5:30 a.m., I had to run a few scripts, I have to run a few tests, and then send off the matching results for the Israeli psychology master's match to about 1,000 eager and impatient BA psychology students in Israel, waiting to see whether or not they got a place in a master's program next year in psychology. So let me tell you how this came about. Okay, I have to take you about 5 years back and explain what is this market for psychologists and why did we get into it, and what did we learn from redesigning it. So the way to become a clinical therapist in Israel is to first do your BA, and it's really difficult to get in. Then you have to do an MA in clinical psychology, and here the funnel is really, really narrow. There is really not a lot of places, I'll tell you in a minute, and then you do an internship. So we have about 2,000 BA graduates in psychology each year. Of those, most of them try to apply to an MA. Most of them want to become clinical therapists. The others that don't apply, it's only because they realize they don't have any chance, okay? And we have about 300 positions in clinical psychology, and for the rest of them, we have 250 positions in research tracks, like organizational psychology and so on, so most of them don't get any position. The competitiveness of this program, of this market, created grade inflation, meaning that students repeatedly took exams until they had high enough GPA, and also used a lot of other, there was a grade inflation, and then they started a uniform screen test. There was also a process of unraveling because institutions also wanted top students. So as always, they started recruiting students in the second year of their BA. And at some point, they decided on a uniform date in which they will do a 3-round process. Basically, the process is first round, which is similar to a first round of deferred acceptance, then second round similar to a round of Boston mechanism, and then exploding offers. This process was really, really bad because it caused both students and departments to be really strategic. Students, because of the Boston mechanism kind of round, that they had to strategically accept offers from departments, and departments tried to offer admission to students who were not necessarily the best, but rather really likely to say yes to their offer, okay? So this was a good reason for us to approach those departments. We approached them and we said, you know what, there is a really good way to solve this. We can do centralized matching. We studied deferred acceptance at school. We know how to do it. Maybe you want to do it. It was really, really easy to convince the professors to do it because professors are typically smart. They heard about matching and market design and so on. It was more difficult to convince the applicants to go along with this program because psychology students tend to be highly paranoid and very emotionally unstable. So let me give you an example. Okay, so the results, I send them out today, but yesterday I sent an email saying that tomorrow you're going to have results. These are 2 reactions that I found on Facebook. One of them is there any chance that today's email is just trolling by some board secretary at the matching center? Yes, sure, that's what I do, you know. I troll applicants because I like to do it, so that's the paranoid stuff. And as for the emotionally unstable, I can share a different reaction that I found. Now, this one I don't even need to translate, I think. Let me just highlight the fact that in Hebrew, the combination of birthday surprises, yellow birds, and ice cream means the same as in English, okay? Which is nothing. Okay, so somehow we managed to convince them to go along with our matching program, with our matching system. And okay, this one I have to translate for a few of you, like the 20% that don't know Hebrew here. What I want you to see is mostly that here there are different institutions. Okay, you see this is one institution. Here you can find different tracks within the same institution. So you can be matched with a certain institution or even a certain program, but you can have different terms. And here you have all the rankings of the different options, okay? And you can rank different terms differently. This is what we in market design call matching with contracts, okay? Matching with contracts, meaning two agents are contracting, but they can have different terms. For example, different study track, different terminal degree, are you studying for an MA or for a PhD, and different funding opportunities. This is really important in college admissions, okay, different tracks. This is really important even in the psychology admissions because you have different program and different funding opportunities. And one of the things that we realized was that in our case, preferences were not substitutable, but they were almost substitutable in a certain sense, okay? And if you want, you can read about it in the full paper. What today I'm going to talk with you about is what is the size of the core in large two-sided matching markets with contracts. So what do we know about the size of the core? The size of the core means the number of stable matchings that are possible in this market. So there are a lot of papers on how the core is small, how there are not that many stable matchings. For example, the rural hospital theorem already says that it's the same set of students which is matched in every stable matching. And then you have a bunch of papers, one after another, that all show that whatever the situation is, the number of stable matching is not big. You can see it in the NRMP data, and then all those papers talk about how if the lists are short, you're likely to get a small core. And Yash paper with Itai and Yaakov shows that in unbalanced market, you also get really small variation in rank for the students and for the institutions. Across all stable matchings, when there is a continuum of students, there is just a unique stable matching, and so on. So what are the implications of these results? Mostly that even though no stable matching is truthful for both sides, and you do know that deferred acceptance is truthful for one side, it is approximate truthful for the other side because of the small core, okay? People cannot successfully manipulate. You have a truthful epsilon Bayes-Nash equilibrium, and you have an equilibrium in which most people tell the truth, okay? So there's not much point in studying different stable allocations. So this literature definitely missed a big part, at least the part that we thought was important, which is what happens when you add contracts to this matching environment, okay? We realized it was important, so we tried to take a large two-sided random market matching, large matching market, but now add contracts, okay? So what's the result? The core is, that's a typo, sorry. The core is large, okay? That's a typo. The core is large. Why is it large? So before I tell you why is it large, let me tell you that it is large both in theory, okay? You can build a model in which it is large. In fact, every model that we tried, we got a large core, and in the data. And I'll tell you about it. And also allocations differ substantially, meaning that the rural hospital theorem does not hold, okay? It does not hold in a very certain sense. I'm going to explain in a moment. Let me show you an example. You have M applicants and schools, okay? I'm going to use schools program exchangeably. So each school each school has funded and unfunded seats, but capacity is just one, okay? And all contracts are acceptable. Each student can go to the school with funding or without funding. Preferences are in the natural direction, meaning that students like money, and schools also like money, okay? They don't want to give their money away. And what I claim is that the number of stable matching is exponential in the number of students and schools, okay? This is really easy. Why is this the case? Because if you care about money, but you don't, sorry, I didn't say it. you don't care about money as much as you care about the agent that you are matched with, okay? And if this is the case, I can take just any stable matching and transfer money from the school to the student and vice versa. I can pick whatever transfers that I want, whatever contracts that I want, okay? So because of that, I can just pick any stable matching and create a lot of other stable matchings. That's really easy, okay? This is a large core, but I would say this is a boring large core, okay? Because it's big, but it's nothing really interesting happened here yet, okay? Here's a second example. You have one school with two seats. One is funded, one is unfunded. And you have two students. One of them is, I'm going to call her R because she's rich. And the other one is P because she's poor, okay? The rich student likes to get funding, but it is also acceptable for her to go to school without funding. The poor student cannot go to school without funding, okay? The school itself does not care whether they give funding or not. They don't care about funding at all. They only care about the composition of students. So they like to get both students. They don't care who gets funding. If not, if they can't get both students, they like to get the rich student, which is better than the poor student. Okay, so if we run the applicant proposing deferred acceptance, what we get is that the rich student gets funding, and the poor student is left unassigned. Okay. If we look for other stable matching, we can find this stable matching in which the poor student gets the funding and the rich student does not get funding but is assigned also to the school. So what happened here? Now we have different set of students assigned under different stable matchings, right? And why do we have that? Because we have a budget constraint. Budget constraint means that preferences are not substitutable, meaning that the rural hospital theorem does not hold. Okay, and also note that the school prefers the blue matching, and also the poor student prefers the blue matching, okay? And the rich student prefers the red matching. There is also no applicant optimal stable matching. Those two examples can be generalized to to an extended environment. So we look at a many-to-one Kojima-Patak kind of model, okay? Many-to-one market with responsive preferences, short lists, random preferences within those, and we assume that if I like some contract, then I also like the funded/unfunded version of the same contract, meaning that it appears in my shortlist. Results are there are many stable matchings, exponential in the number of scholarship. This is exactly the extension of example 1. And different stable matchings have different sets of matched applicants. This is the extension of example 2, okay? A lot of different applicants are being assigned, the linear fraction. The implication is that first, there is a natural manipulation under the applicant proposing deferred acceptance for the schools. If I'm a school that has a funded position and an unfunded position, I can look at an applicant who is rich and just remove the contract in which the rich applicant gets funding. I'm still going to get the rich applicant because she doesn't care about funding, but I'm also going to keep the funding to exploit the funding to lure another student who is poor, okay, and that would otherwise not come. And that's also in a large market. It also means that if we look at the market as a whole and we can decide whether to give funding based on merit or use need-based funding, if we'll take need-based funding, we'll have much more students than if we use merit-based funding, okay? We'll have different composition of students. It would make, if we only use the preferences to determine who is rich and who is poor, it's going to become not strategy-proof for the students to really declare their preferences, right? But if we use some observables, like how much do your parents make, we can still do it strategy-proof. Okay, so some data, 5 minutes, good. Some data from the psychology match. In the psychology match, we have about 1,000 applicants, about 50 programs, and programs care about the identity of the students, but not about who gets funding. How do I know it? How do I know it? Because I talk with all of them. Okay, I know they don't care about funding. They ask funding from the dean, and then they they can use it as much as they want, but they don't care who gets it. Participants rank on average 4.3 contracts. Why do I tell you that? Because it means that the shortlist assumption is relevant in this market. And a lot of them rank some program that has a funded and unfunded position. The number of stable matchings in this market is indeed exponential in the number of scholarship. Okay, it's really a lot of stable matching. Yes, yes.
Do you have the income data?
The what? No, I don't. Well, I have survey data about their income. I didn't check whether it how it correlates with their preferences. Okay.
You have it on the next slide.
Yeah. But I do have it on the next slide. Thanks, Ron. Yeah. Okay, so that's kind of like showing you that example one works. Okay. Here is a better market. Okay. The Hungarian college admission market, in which there are thousands of programs and tens of thousands of applicants, and a lot of the programs have a lot of funded seats. Okay. Again, participants rank not that many contracts, again making the shortlist assumption relevant to this market. A lot of them rank only funded seats, meaning that's what we call poor, and those who rank the non-funded seats sometimes put them after all the funded seats, which also means that they are poor. Okay, they like the funded seats above the non-funded seats. But out of those who do get funding, there are about 4% who rank the same program without funding immediately after they rank the program with funding, meaning that if we took their funding and gave it to someone else, they would still take the same program. Okay, they would get the same program and the matching would remain stable. So we can move around funding and get about 2% more students in each year in the college admission in Hungary, 2% more college students in the entire country. That's a big change, okay? And here we do have observables on income, but what do you want to say about them, Ron?
It's the poor people that
yeah.
are going to get it.
Yes, it's the poor people that care about funding. I mean, that makes sense. So that's like an extension of example 2. Here it's only, in example 2, it was 1 student and then became 2 students that are enrolled. Here we have only 2% more students, but 2% is a big thing when you think about college admissions. Okay, so summary, contracts are really important in matching markets. Maybe not in school choice, but whenever you get out of school choice scenarios, really important. Markets with contracts are really different from markets without contracts because, for example, there is a difference between stable matchings, and in particular, it means that DA is not approximately strategy proof. You can manipulate it quite easily if you understand what is going on, especially if preferences correlate with observables. Yes, and this one goes without saying. Okay, thank you.